Hello, Manish Chaudhary, are you there?
Yes, sir.
Okay, okay. So from which college you are, or like are you M.Tech student or B.Tech student?
Sir, I am B.Tech student.
Okay, okay. So why did you take this course?
Sir, in my college it is compulsory.
Okay, compulsory. So this credit will be added to your this course credit
Yes,
will be
sir.
added to your grade, right?
Yes, sir. Yes, sir.
Okay. So like, are you joining it first time? This like this.
Yes, sir.
Okay. Okay. We will wait for few more minutes because like other than you, no one is there. So like just wait for 5 minutes so that others can join. After that, we can start.
Okay, sir. Okay.
Izadul, are you there? Ijazul Rahman.
Yes, sir.
Yeah, yeah. See, only two students are there, so we are waiting for few more minutes so that others can join, and after that we can start.
Okay, sir.
Okay. Chaudhry, Manish, and Izadul Rahman. Have you completed week 4 videos? Like, have you seen all the videos in week 4?
Yes, sir.
Yeah,
Yes, sir.
yeah. So we can start solving questions for week 4 content. Okay, guys. Are you able to see the question assignment 4? Are you able to see?
Yes, sir.
Yeah. So can you answer the question number 1? Okay. Other than that, if you have some doubt, then you can discuss that doubt. You can ask that doubt. Chaudhry, Manish, and Ijazul. If you have some doubt in the previous week, that you can discuss with me. Hello.
Sir?
Yeah. Manish, if you have some doubt, you can discuss with me, or otherwise I can start.
No, sir. I haven't any doubt.
Okay, fine. Okay, so are you able to see the screen?
Yes, sir.
Yeah. So please answer question number 1. This is week 4 content. All the questions are from the week 4 content, from the week 4 syllabus. All the questions are from that syllabus only. If you have completed week 4, then you should be able to answer. See, ordinary mass diffusion of species in a multi-component mixture occurs due to these four options are there. See, this is bulk flow of the mixture. If there is a bulk flow of mixture, then that is not a diffusion. Second is gradient in the mass fraction of species. Third is gradient in the temperature. Fourth is change in pressure in the flow direction. Okay, so what is fixed law of diffusion? Can anyone tell? What is fixed law of diffusion? Manish, can you tell me what is fixed law of diffusion?
Sir, I don't know.
Okay. This is the fixed law of diffusion. So what is y? Y is the mass fraction. Mass fraction of any species. So how the mass fraction is varying along the x direction. So this is mass flux. So mass flux depend on dy by dx. This is mass fraction. Consider species A. Then the mass fraction of species A dya by dx. So this is the mass flux. So now can you answer this question? In ordinary mass diffusion,
So according to Fick's law concentration gradient, so here gradient of the mass fraction of the species, I think.
gradient. Sorry, can you repeat? Uh, can you repeat? Can you
So
repeat the answer?
concentration according to Fick's law,
Yeah,
the multi-component mixture occurs the gradient of concentration. So gradient of in the mass fraction of the species.
yeah. That is the correct answer. That's it. That is the correct answer. Gradient in the mass fraction of the species. That is the correct answer. Okay.
It's B, sir, है ना?
Yeah. Okay. So question number 2. Can you tell like sum of diffusion fluxes of all the species in the multi-component mixture is equal to? Question number 2.
Zero.
Yeah.
It's 0, sir.
Yeah. Zero. Uh, I hope it is clear to everyone. Question number 3. Question: velocity of a species in a gas mixture is calculated as the sum of. Yeah, this is covered in the lecture videos. The two options are there: velocity of the mixture minus sum of velocities of all other species. It's diffusion velocity plus velocity of the mixture, and two other options are there. Yeah, velocity of the mixture minus the diffusion velocity of a species, and velocity of mixture minus its diffusion velocity.
Sir, species velocity is equal to, sir, the mixture velocity and plus diffusion velocity.
Yeah. So the
Veloc-
right
so,
answer is
so
B, right?
sir, it is
I think the
yes,
right
yes.
answer is B.
Yeah. It's correct. It's correct. So is this plus or is this minus? Why
It's
plus?
plus,
If,
sir.
if you see this, the equation is something like total mass. To equation is total mass flux is equal to the rho density of species A into velocity of A. This is if you see minus rho density of the mixture rho into d into diffusion coefficient into d y a by dx. Correct? Is this not minus? So the answer is minus or plus. If you see the ppt, I have those ppt with me.
Sir, it is plus only.
It is, if you see this, so is this minus or plus? If you see this ppt, there is a minus sign, right?
Yes, sir.
So why it is plus? You see, your answer is correct, it is plus.
Sir, it
Okay.
is a gradient, negative gradient of the concentration with respect to the distance.
Yeah.
It is negative. Actually, velocity is positive, but the gradient is negative.
Okay. So basically, you are saying dya by dx is negative. So when it is multiplied by minus sign, it will become positive, right? Is it so? So what do you mean by Harsh Patel? I think you was speaking. Who was speaking?
Yes, sir.
Yeah. You were saying something like gradient is negative. What do you mean by gradient is negative?
That is the concentration gradient which, of the species A with respect to the other species in the mixture. That is negative. and this is the cause of the diffusion.
Harsh, I am not getting. What do you mean by concentration gradient of species A with respect to other species? What do you mean by
That is
respect?
the number of molecules of the species A with
Supposedly it
in
is.
the mixture from one location to another location.
Yeah, so
That is from x to x plus delta x. What is the the number of molecules available when you are moving from x to x plus delta x?
yeah, so with respect to like along the x direction, not with respect to. Is it right? Why with respect to other species? It is along the x direction. Concentration along
Yes,
the x direction, right?
yes, sir. Yes, sir. Yes.
So, so, so you are saying like dya by dx is negative. This is what you are saying. So when dya by dx will negative, and it is multiplied by the negative sign, so it will become positive. Is
No,
it?
no, sir.
Yeah,
Velocity is altogether a positive diffusion velocity, but that gradient is negative, and hence that negative sign is carry forward
yeah,
outside the bracket. That becomes the
yeah,
appears as a negative to us.
yeah. I got it. I got it. Same thing. I got it. Okay, okay. So question number 4. Can you answer question number 4?
Saturation pressure to the atmospheric
In,
pressure.
in the third question,
Yeah,
the answer is
yeah. Third question. The answer is it's diffusion velocity plus velocity of the mixture. Basically,
okay,
this
sir.
is the bulk velocity of the mixture. Do you have some doubt?
No, sir.
Okay. So question number 4. So you are saying like saturation pressure at the interface to the atmospheric pressure.
Yes, sir.
Why not one? Saturation pressure at the interface to the total pressure.
Sorry, sir. I'm not.
Why
Pardon.
why not one? Why not one? There like one is saturation pressure at the interface to the total pressure.
Actually, sir, in the sir has we have just gone through the video of the sir in
Yeah.
the solved example. In that, he has taken the this ambient only saturation upon the ambient.
Okay. See, the thing is, up to my understanding, see, this is suppose that if the reaction takes place, like suppose that you have some, I can say that some droplet you have, and it is evaporating in ambient condition. Then you can say that saturation pressure upon ambient pressure, because ambient pressure is the total pressure. But if the condition is not ambient, then you cannot say that like then it will be like saturation pressure divided by the total pressure outside the liquid. Do you agree?
Sir, can you please elaborate it more?
Yeah. See what I am saying. Suppose that there is a liquid droplet, and it is evaporating in the ambient condition. So what is the total pressure outside the liquid, outside the droplet? P total is P ambient, right?
Yes, sir.
I am asking in this region what is the pressure in this region? In this region, what is the
Yes, sir.
total pressure?
Atmospheric only.
P total is equal to the P ambient, right? P ambient.
Yes, yes, sir. Yes, sir.
Now suppose that someone wants to join. Kunal Kumar Chaudhary. Okay, so now consider the case where droplet is now consider the case where some droplet is there, some droplet is there, and it is evaporating inside a box, and the pressure inside the box is not ambient, it is some different pressure.
Okay.
Okay,
Okay.
so
Okay, sir.
you like every time it cannot be ambient, like atmospheric pressure, but in some cases atmospheric pressure is valid, but in every time we cannot say that it is atmospheric, it is every time we cannot say that it is the atmospheric pressure, the total out, like total pressure is atmospheric pressure. Do you agree? Hello?
Yes, sir. Yes, sir. Now got it.
Yeah. And what about Others, Ijazul and Manish, is this clear to you?
Yes, sir.
Okay, okay.
Yes, sir.
Yeah, yeah, yeah. Okay, question number 5.
Negative and constant.
Negative and constant. Okay, okay, Harsh. Why it is negative? Oh, wait, wait, wait. And what about other? Can anyone else answer this question?
It's
Sir,
constant.
it is constant.
Constant and
Constant
positive.
is
Oh, yeah, 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 yeah. One by one, please. Constant and
Constant and positive.
constant and positive. Okay. And what about other? One more student was saying something.
sir, constant and positive.
Constant and positive. Okay. So basically, it is asking uh, what is the in spherically symmetric vaporization of the liquid fuel droplet, the slope of temporal variation of its surface area. See, remember, it is asking surface area, right? So what is the d square law?
There is a negative k. That is what we got. That is a constant.
Okay, okay, okay. Harsh, your answer is correct. No problem. Just like I want to elaborate it to some other student. Okay, so this is the d square law, right? Ijazul and Manish, this is the d square law. Do you agree? K is
S- No, sir, can't agree. No, sir, can't understand, sir.
okay,
Please repeat again.
okay, okay, okay. See, d square upon dt is equal to the minus k is equal to the minus rho d. This is this like wait rho d upon there is a constant. I think the constant is 8 rho d upon rho into l. 8. Yeah, this is the d square law, right? Yeah, bro, do you agree or not? Is a minus 8 rho. This is the density of the air, d diffusion coefficient, density of the liquid into ln 1 plus b. Is that a Spalding constant b? Hello, hello. Did you study this?
Yes, sir.
So, do you agree with this or not? Or there is, do you want to say something? Manish and Ijazul.
Okay, sir. Okay.
So, do you agree?
Yes, sir.
Yeah, yeah, yeah.
Yes,
So,
sir.
see, the
Yes, sir.
density of the liquid is constant, density of the air is constant, the diffusion coefficient is constant. What is By? That is Spalding's constant By. Yeah, this is y naught minus y infinity. Suppose that one droplet is there and this droplet is evaporating. So here the concentration mass fraction of liquid, maybe this is a water droplet. So mass fraction of that water vapor near to the surface, and y infinity mass fraction of water vapor far away from the surface. So this is By. Hello. Yeah,
Sir, yes, sir.
yeah. So By y naught. What is y naught? Can you tell me what is y naught? Yeah. Anyone, even Harsh, can you tell me what is Y naught? Can you calculate how to given temperature? Suppose the temperature is T. At temperature T, how will you calculate Y naught?
It is the mass fraction, and that we can calculate from the mass fraction at the interface.
Mass
So for
fraction.
that
Yeah.
we must.
Yes, yes, I'm getting. I'm getting. You please.
Okay, so mass fraction at the interface, if either of the mass fraction must be known to us, either of the species. So if the let us say the droplet mass fraction is given at the interface, so one minus is
No,
the
no, no.
mass fraction of uh,
Okay.
the ambient.
Okay, okay, okay. Suppose that if mass fraction, suppose that consider this is a water droplet. Consider this is a
Okay.
water droplet, and now you are supposed to now you want to calculate Y naught, and the temperature is given at 60 degrees Celsius. How will you calculate Y naught and nothing else is given? Can you calculate?
Uh, Sir, why not or why infinity?
See, I am asking Y naught. Why infinity that you have to either given or you will assume Y infinity 0.
Yes, sir. It is in the far away from the interface. If the ambient is not having that species, we can consider it as a zero.
Yeah, Y infinity we can consider 0, but why not? What about Y naught? I am asking why not Y infinity.
Sir, it is from the partial pressure. If the
Yeah,
from the temperature of the interface, we
yeah,
have to see the partial pressure, and
yeah.
then we have to take the ratio of partial pressure to the total pressure.
Okay, so what is partial pressure? What is partial pressure at the surface? Here,
That
what?
is the saturation pressure at the
Yeah,
given temperature of the interface.
yeah. That what I wanted to listen. It is the saturation temperature, saturation pressure. So we will calculate the saturation pressure at temperature 60 degrees centigrade. So that is the partial pressure. That is the partial
Yes,
pressure
sir.
at the surface.
Yes,
That
sir.
that will give the partial pressure. And what is total pressure?
Hmm. Total pressure, if it is a ambient, that is a only air, which is a dry air, then it should be the atmosphere. Otherwise, as you told earlier,
Yeah, yeah,
it
yeah.
should be the
I agree.
total pressure.
I agree. I got it. I got it. So with that we will get the total pressure. Now we will calculate mole fraction, right? P by Q
Yes, sir.
naught, and from
Yes.
mole fraction we will calculate the mass fraction, and this is how we will get Y
Yes.
naught. Okay, okay. So
Uh,
where we were? So this Y naught is constant. It depends on the temperature. So given temperature, Y naught is constant. Y infinity is constant. So By is constant. Now in this case, if you see for a given condition, rho d, rho l, and By, everything is constant. So this whole this whole term is everything is constant inside this equation. Everything is constant. So this is constant k, and this is multiplied by the negative sign. So dt square by dt is equal to the minus k. Hello? Yeah. Do you agree? Do you have some doubt or? Uh, Manish, and I think you were asking doubt. You were having some doubt.
No, sir, no.
Okay. So, this answer is negative sign, right? Slope should be negative, or it will
Then
be
it's C, constant and negative.
constant and negative, constant and negative. Now, question number 6. See, in question number 6, you are supposed to know a formula that is there. That only then you can solve this question. If you don't know the formula, you cannot solve this question. There is a formula to calculate the diffusion coefficient of a mixture if the diffusion coefficient of two binary species are given. So the formula is, I will tell you the formula, and after that you try to calculate. So it is there, already covered in that, already covered in the in the lecture video. The formula is diffusion coefficient of species I in the mixture is equal to the 1 minus, this is the mole fraction of species I upon summation of xj upon dij. This is the diffusion coefficient of species I in species J, and this is the mole fraction of species I, and there are total, suppose that J number of species are there, excluding that species I, summation of Sj upon Dij. This is how you will calculate diffusion coefficient. Can anyone calculate the diffusion coefficient? I will show the question. You write this formula and I will show the question. This is the question. So now you try to calculate the diffusion coefficient. Are you calculating? Just you need to use the formula and substitute the value, you will get the answer. Okay. Harsh Patel, are you calculating?
No, sir. Actually, I'm wondering for my calculator. Actually, I'm looking for my calculator. Actually, I got the formula.
Okay.
Uh,
Okay.
sir, I had a confusion.
Yeah.
Sir, here it is asked that we have to calculate diffusion coefficient of H2.
In the mixture.
So, yeah, so we have to take the species into consider H2N2 and O2H2 only. Na? We have to neglect the N2O2, if I'm correct.
See, species. Wait. I didn't get your. I didn't get your question. What you are saying?
Sir, it is we want to calculate the diffusion coefficient of H2.
Yeah.
Okay.
Yeah.
So in the denominator,
Yeah.
it is a sigma xi j dij.
Yes.
Correct?
Yes.
So in this case, as we want to calculate for H2, so we have to neglect the diffusivity for N2O2.
Yes. Exactly. Yeah.
Correct? Na?
Yeah. What about others? If you are not having your calculator, it's very easy. See, if I don't know if I can write this. Oh, okay. Now, question is also there in front of you, and that formula is also there in front of you. So, can you solve it? Anyone else? Can anyone solve it?
We are
Kunal
not
Kumar,
having the formula.
can you solve it? Kunal Kumar.
Sir, we are only able to see the question. Sir, the formula is not actually visible to us.
Okay. Is the formula visible to you? Are you able to see the formula?
No, sir.
No. Okay, formula is not visible to you. Okay. is this visible to you now? Are you able to see now? Is Azul, are you able to see now?
Yes, sir. Yes, sir.
Yeah, yeah.
Answer is 2.589 or 2.616. Closer to that.
No. See, you check your calculation. Answer
Sorry,
is
sir.
not 2.616. It's getting the exact answer. No issue.
Sir, the doubt is,
Yeah.
as I asked you earlier also,
Yeah.
shall we consider the diffusivity for N2O2 in the calculation?
No, not N2O2. You need not to consider
Only
N2O2.
N2H2 and O2H2 only. We
Yes,
have to consider it for.
yes. Yeah, yeah, yeah. And you are getting, see, like I am getting the exact answer. Yeah, you have done some calculation mistake, some silly mistake you have done, I think.
Just a minute.
Yeah, yeah, yeah.
Sir, 2.445.
2.445, yeah, that is correct answer. Okay, so should we move to the next question? Everyone agree? Like anyone is having some doubt in this question? If yes, please let me know.
Sir, can you please show the solution?
Okay, okay, okay. So 1 minus xi is the mole fraction of H2, right?
Yes, sir.
1 minus 0.15 upon fj is the mole fraction of other than I is 0.2 is the mole fraction. 0.2
Yes, sir.
upon 0.2 is the mole fraction of O2, right? O2 and H2,
Yes,
2.56
sir.
2.5668 plus 0.65 upon 0.65. Wait. This is 0.2 is the mole fraction and 0.65 is the mole fraction of N2.
Yes.
So N2 and H2, 2.4095 upon 2.4095, 4095. If you calculate, what you will get? Yeah, what you are getting if you calculate this? Harsh?
Yes, sir.
Yeah.
Yes, now I'm getting
Okay.
2.44.
Okay. 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 So question number 7. Try to solve the question number 7. Sorry, not question number 7. Yeah, question number 6. Yeah, question number 7. Consider a water droplet evaporating into air at 1 atm 80 degrees Celsius. Mole fraction of water vapor at the interface is 0.6. If the mole fraction of water vapor at 50 times the droplet diameter is 0.01, the Spalding transfer number is, basically this is asking By, right? This is the Spalding transfer
Yes, sir.
number By. So this is By. Y naught minus y infinity or 1 minus y infinity. Now you need to calculate By. Take your time and solve. Is question clearly visible to you? Can you see the question clearly? Or should
Yes,
I
sir.
zoom?
Sir, this 50 times is at what value? At the interface or?
See, see, this is question number 9. So we are solving the question number 9. We didn't solve question number 7 and 8. So after that, after question number 9, we will solve question number 7 and 8. This is question number 9, right? Consider a water droplet
Yes.
evaporating at 1 atm 80 degrees Celsius. Mole fraction water vapor at interface is 0.6. If the mole fraction of water vapor at 50 times the droplet diameter. Yeah. Harsh, you were asking something.
Yes, sir. So it is at the interface, sir, this condition that 50 times the mole fraction value that we are, it is 50 times the droplet diameter.
Yes. Yeah. You are saying something. I'm not able to hear you.
Sir, this is the last sentence. It is at what condition? It is at the interface.
You are saying like this: if the mole fraction of the water vapor at 50 times the droplet diameter is 0.01,
Hmm.
right?
Yeah. So this mole fraction value is at the interface or at what place in the space?
Yeah, I am getting your question. I am getting your question, but I don't want to answer. I want you to think. Just think about it. You will get the answer. Just think about it. It's clear in the question. Like what space it is indicating. Is it indicating infinity? Is it indicating the surface temperature, or what it is saying? It is saying like 50 times. If it is saying 50 times the droplet diameter, then how it can be a surface concentration at the surface? How it can be the mole fraction at the surface? If it is saying at 50 times, you have to think like what the question is saying. Yeah, I can understand there is little bit confusion, but if you just think, you will get the answer. Question number 9.
It is at the ambient, sir.
It is at the ambient, so it is indicating the basically mole
Why
fraction.
infinity?
Yeah, it is giving the mole fraction at the, sorry, mass
Yes,
fraction at
sir.
the mass fraction at the infinity.
Sorry, mass fraction.
No,
Yes,
no, no,
yes.
no, 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 no. Here mole fraction is given, not mass fraction. Mole fraction of
Yeah.
water vapor, not mole. So you have to calculate the mass fraction from the mole fraction. It is
So
mole
at the
fraction
80 degree, we have to calculate the saturation uh,
pressure.
pressure,
Yes.
and then uh, yes, mole fraction of the water vapor at the
Here you
interface.
need not to calculate the saturation pressure, because they have
No,
given the
no,
mole
it is
fraction.
already given. It
They
is
have
already
already given
given.
the mole fraction.
Yes. Sir, we have to calculate the first of all molecular weight of the mixture
Yeah.
based on the mass fraction, sorry, mole fraction,
Yes. Yes.
and then we have to calculate the mass fraction accordingly.
Yes. Yes. Exactly.
So it would be something like this. At the interface, the molecular weight is zero point 0.6 into zero point 0.6 upon 18 plus 1 minus zero point 0.6 upon 28.84.
Wait. Wait. You are saying. You are saying. Okay. You are saying like point. Okay. So molecular weight of mixture. You are saying molecular weight of mixture is equal to the at the interface is equal to the what you are saying 0.6.
That is 1 upon zero point 0.6 upon 18 plus zero point
Wait.
0.4
See.
upon.
Zero, you said 1 minus 0.6. What you said?
Sir, that is for the air.
Yeah. Yeah. That is for the air.
That is for the air. One at the interface, it should be 1. So 1 minus zero point 0.6, that would be zero point 0.4 for the air.
Yes. 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 So how will you calculate the molecular weight of mixture?
Sir, it is 1 upon the sigma xi mi. Sir, molecular weight comes around 21.18.
This is the molecular weight of mixture. You are saying, right?
Yes, sir. Molecular weight of mixture. Is it correct, sir?
No, this is not correct. 1 upon summation xi into mi. Not 1
Yes,
upon.
sir.
It is summation xi into mi. It is summation xi into mi, not 1 upon summation xi into mi. Molecular weight of mixture, it is not 1 upon summation xi into mi. If you do 1 upon summation xi into mi, how you will get 21 or something?
Molecular weight of mixture 16.72. I'll
16.
get, sir.
You are getting 16.72. See how you are getting.
16.7.
Okay. So this is they have given 0.6 is the mole fraction of the water vapor at the interface. So molecular weight of water vapor is 18 plus 0.4 into molecular weight of air. What is the molecular weight of air?
18. Sorry, 28.84.
28.84. Now if you do
Yes.
the
Yes.
calculation, what you will get?
22.33.
0.6 into 18 plus 0.4 into 28.84. Yeah, 22.336. 22.336.
Yes, sir.
Yeah. Ijazul, what you was doing? Why you was getting something different answer? May I know what you was doing? What did you do?
Uh, I took the ratio of the. Actually, I wrote the wrong formula. It is I wrote the mass fraction upon the molecular weight.
Okay, okay, fine. So, okay, so is this how to calculate the molecular weight of mixture? Is this clear to everyone, or is this like someone is having in this formula itself doubt in this formula itself? This is wrong. This is wrong. Molecular weight of mixture is equal to the summation of xi into mi. So this is clear to everyone, right? Or someone is having doubt in this formula itself, because you don't know how to calculate this formula, then you won't be able to solve this question. I hope it is clear to everyone. Okay, so anyone is getting the answer question number 9? The Spalding transfer number, is anyone able to calculate?
Sir, I got the mass fraction of the water vapor at the interface is 0.483.
Mass fraction, basically at the interface you are getting 0.83.
0.483.
0.483. Okay, so okay, we will calculate the mass fraction at the interface. Here they have given mass fraction at the interface. So first we will get mole fraction. So what is the mole fraction at the interface that we have? Mole fraction at the interface x is equal to the 20, x mole fraction at the interface 0.6 into the mole fraction is already given. Mole fraction, so you will get mass fraction 0.6 into molecular weight of water vapor into 18.
Water
So like we need not to calculate this.
is YWI.
Yeah, so here it will be y YWI, basically mass fraction of water vapor at the interface is equal to 0.6 into 18 upon molecular weight of mixture. It was coming around 28, right? 28 point
Yes, sir. No, 22.336.
22.336. It was coming 22.336. 22.336. 0.4835.
Yes, sir.
0.4835. Everyone is getting this. Everyone is getting this. Rajesh, are you getting this? Rajesh, are you there? Okay, Manish, are you getting this? Mole fraction, sorry, mass fraction
Yes,
at the
sir. I
interface.
am solving, sir.
Okay, you are sorry.
Sir,
Yeah,
sir, I solved the WY infinity. It turns to 6.265 into 10 raised to minus 3. Is it correct? At the infinity?
yeah, it,
Mass fraction of the what?
yeah, it may be correct. See, you are saying y infinity.
Yes.
Y infinity is equal to the, they have given 0.001 into 18 upon, now 0.00,
Sir, 0 point, not 001, it is
yeah,
point zero 0.01 only.
it's point 0.01.
Sir, I did the same thing. The calculation of the molecular at the interface. So same thing I have applied the same thing at the infinite distance.
Yeah, are you getting this 6.26
Yes, sir.
percent? Okay,
Yes, sir. And I also got the spelling number. It is 0.924.
0.924.
Yes, sir.
Yeah, I think that is correct, but I'm not sure.
Yes, it is there. It is one of the option.
Yeah, one option is there, so I think it is correct. Just I want this answer from someone else, and after that I we will move to some other question. Rajesh, V, are you there?
Sir, it's also, sir, 0.924.
0.924. So yeah, 0.924. That is correct answer. Okay, I think this guy left. Rajesh, V, after joining the meeting, he left. Okay. Is Adul Rahman, are you getting 0.924?
Yes, sir.
Okay.
Okay.
Okay. So we will move to question number 7. Question number 6 we have completed. Question number 7. It's question number 7. No, not this question number 6. Question number 7. This is question number 7. A mixture of 1 bar 298 Kelvin. This is the question number 7. Question number 7. Okay. So we need to calculate the mixture velocity and the velocity of particular species are given.
Sir, first of all, we have to calculate the mass fraction. Molar ratio is given.
Yeah. Yeah,
Also,
mass fraction. Yeah, you
after
have to calculate the mass fraction, or there is other way. Yeah, you have to calculate the mass fraction. Mass fraction. Yeah. Yes.
so it is first of all we have to calculate the molecular weight of the mixture, and then after we can get the mass fraction of each of the species.
Yeah. Yeah. Then you multiply with the velocity of each of the species, and you will get the bulk velocity. Right.
Yes, sir. That is a rho A into VA plus a rho B into VB.
Yes. Yes. Divided by bulk density. That will give the bulk velocity, right?
Yes, sir. So
Yeah.
it can be written as rho into YA into VA.
Just give me a minute. Just give me a minute. Okay, question number 7. Yeah, yeah. What you are saying? Can you repeat? Harsh, can you please repeat?
Sir, first we have to calculate the molecular weight of the mixture,
Yes.
and then after we can able to calculate the mass fraction of each species.
Yes.
after getting the mass fraction, it is what they have asked, uh, mixture velocity.
Yes.
It is V that they have asked for.
Yes.
So total velocity, it is rho a into VA plus rho B into, no sir, it is not like that.
Okay.
I think there is some tricky part in this question.
See, there is. I don't think there is any tricky part in this question. But if you see, if you use, you need to use this formula only. That's it. See,
Okay, so
so
we have to
this
calculate rho
y of
mix.
one second, y of a is equal to the rho a upon rho of mixture. Do you
Okay
find
sir.
any confusion in this? So you need to
No,
use
no,
this.
no. No, no, sir, not at all.
You agree, right?
Yes, sir.
So you need to use this. That's it, and you will get the answer.
So simply we have to, if we are having the mass fraction with us, we can
Yes.
directly get the mixture velocity.
Yes.
So it is YO2 into VO2 plus YH2 into VH2.
Yes. See, this is, even you need not to remember this formula. If you see, the mass is like total mass flow rate of the mixture is equal to mass flow rate of A plus mass flow rate of B. That's it. There are two species A and B. So mass flow rate of A plus mass flow rate of B is equal to the total mass flow rate.
Yes, sir. Sir,
Yeah.
mass fraction of O2 is zero point 0.8 and for H2 it is zero point 0.2. Is it correct, sir?
Wait. Question number 7. First thing here, mass fraction is not given. They have given the mole fraction,
No, I
which
have
is not
calculated the
known.
mass fraction.
Yeah, if you have calculated the mass fraction, then it's fine. And then you should be able to get the answer. You have calculated the
Sir, V mix is, is it 20? Sorry, 12 meter per second?
V mixture is 12 meter per second. You are saying question number 7. Okay. Yeah, one answer is there, 12 meter per second. Yeah, I think that is correct. I'm not sure.
Because sir, the mass fraction is totally inverse of it is for white O2 it is zero point 0.8 and for H2 mass fraction is 0.2.
So this is like in this case it is inverse, but in every case it won't be
Yes,
inverse.
yes.
Yeah.
Yeah, it is by chance it is
By chance, yeah, by
being,
yeah, by chance it is inverse. Yeah.
because molecular weight of the mixture I got is 8 kg per kilomole.
Yeah. Yes. Then it is correct. So I want this answer from someone else, and after that we will move. First thing, I don't know if 12 is correct. There may be something.
Sir, my answer is 11.33.
11.33. Okay, may I know how you are getting 11.33? What formula you are using? Can you tell me how you are getting? I will write in the code. 11.33 means you have done some silly mistake. You are close to 12 only. Whoever was getting 11.33, can you tell me what you did to get 11.33?
Sir, please solve some portion few
Okay.
first time.
See, the total mass flow, suppose that there are total mass flow, like some mixture is flowing, and mixture is having two components, A and B. So total mass flow rate of the bulk mass flow rate is equal to the mass flow rate of A plus mass flow rate of B. mass flow rate of A plus mass flow rate of B. So total mass flow rate means the density of overall density of mixture into area into velocity of mixture is equal to the density of A into area into velocity of A plus density of B into area into velocity of B. So like A is like if you take A common and A is also like we also have A here, so A will cancel each other, so we will have density of mixture into velocity of mixture is equal to the density of A into velocity of A plus density of B into velocity of B. Now we need to calculate velocity of mixture. Velocity of mixture is equal to the density of A upon density of mixture into velocity of A plus density of B upon density of mixture into velocity of B. What is the density? Can you tell me what is density of A? So I want to write density of A is equal to the mass of A upon volume, total volume of mixture, right? Mass of A, and what is density of mixture? Mass of mixture upon total volume. This is V total volume. If you say density of A upon density of mixture, it will come mass of A upon mass of mixture. Whoever was asking this question, is this clear to you?
Yes, sir.
Is this not YA?
Yes, sir.
YA, this is YA. So if you replace here, like if you write like velocity of mixture is equal to the YA into velocity of A plus Y. Similarly, you will get YB into velocity of B. Is this clear? How will you calculate YA? They have given the mole fraction, right? Now we need to calculate mass
Yes,
fraction
sir.
from mole fraction. For H2, the mole fraction is given okay in question number 7. For hydrogen mole fraction 0.8. So YA 0.8 mole fraction. Here you can do 0.8 into 2 upon 0.8 into 2 plus 0.2 into what is other hydrogen oxygen. What is the molecular weight of oxygen? Can you tell?
32. O2 molecular weight is 32.
32. Now you multiply with the velocity into what is the velocity they have given, 20, right? 20 plus, similarly you calculate the mass fraction of oxygen. See here, this mole fraction is 0.8. So what is the mole fraction of, if hydrogen is having the mole fraction of 0.8, what is the mole fraction of oxygen? What is the mole fraction of oxygen? There are two species. Ijazul, I think like whoever was asking this, please tell the answer. What is the mole
So
fraction?
0.2.
0.2 into molecular weight of oxygen. Molecular weight of oxygen. Basically, oxygen molecule I am asking. Molecular weight of oxygen molecule. Molecular weight of oxygen atom is 16. 16 into 2, 32. So we have 32. Now same thing. 0.8 into 2 plus 0.2 into 32 into velocity of oxygen. What is the velocity of oxygen? 10 into 10. You just do this calculation and you will get the answer. Just do this calculation. Can you do this? Someone, whoever was asking this question, can you do this calculation?
Yes, sir.
Yeah, 0.8 into 2 upon 0.8 into 2 plus 0.2 into 32 into 20 plus 0.2 into 32 upon 0.8 into 2 plus 0.2 into 32 into 10. Yeah, can you do this calculation? Okay, if you do this calculation you will get 12. Just do the calculation and you will get 12. I hope it is clear to everyone. If it is not clear to anyone, please let me know. Manish, is this clear?
Yes, sir.
Yeah, yeah. Okay, so we will move to the next question. Question number 7, question number 8. Question number 8. A binary mixture of A and B has the density of 1.2 kg per meter cube. Mass fraction of A varies along Z with distance Z. If the binary diffusivity is and the bulk velocity is, the net flux for A and B at Z is equal to the 0.1 meter r. We need to calculate the net flux. Harsh, are you solving?
Sir, just I'm right now understanding the question.
Okay, okay.
Just I'm understanding how to solve it.
Yes, yes.
I'm just doing my steps in the mind.
Yeah, yeah,
So it is we can get the mass fraction,
yeah.
then the bulk density, the mixture density is known to us,
Yeah, yes.
and the diffusivity of A is given.
Yeah,
Okay, so from that we can able to calculate the mass net flux of the species A,
Yeah.
and from that relation, uh, minus DAB into dA by dx equals to minus dBA into dy b upon dx.
Okay. You try to solve and we will discuss. It will take little bit time, but it's not difficult. You can solve it. It is asking the net flux, not only the flux due to diffusion. It is asking the net flux. It is also given the bulk velocity, right? Any answer from someone?
Sir, mass flux of A is 4.68 into 10 to minus 3 kg per meter square second.
kg per meter square into second mass flux of A. Okay, what is the mass flux of B?
Sir, it can be calculated from that law. Uh, Rho DAB dy x equals to rho dBA dyb
Wait, wait,
upon
wait,
z.
wait, 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 wait. I will write it only then I can think. Yeah, yeah. What you are saying?
It is it is
Wait. Yeah, yeah.
rho
Mass flux. So
into
you are saying
dAb.
mass. You are saying mass flux of B, right?
Yes.
Yeah.
No, sir. Max flux of A. It is how much I got? Uh, 4 4.68 into 10 to minus 3.
Okay, maybe correct. I don't know. I have to check. And like you, what about the mass flux of B? You were saying something like how to calculate or something like that.
It is that dAb into dya by dx equals
No,
to dBA
so
into dyb by
wait,
dx
wait, wait, wait. Say it slowly so that I can write it. Now you are saying DAB. Okay.
into dya by dx.
DYA by DX.
In this case, it is dz.
DYB by DZ, right?
No, no, dya by dz. No.
Mass flux of B.
Okay, that is fine. It is dA then.
DYB upon DZ, right?
No, 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 sir. Sir, actually, what I'm trying to say is once we are having the mass flux,
Yeah.
okay, then we are having that identity that dAb into dya by dx equals to dBA into dyb by dx.
No, 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 I'm not getting. Please repeat it.
It is
Yeah.
here, it should be, sir, this is correct, but in this dya
It should be D by
instead of
A.
dB. Yes.
You are saying this.
Yes, equals to
Yeah.
dBA
Yeah.
into dyb by dz.
No, it's incorrect. It is incorrect. Bro, it is incorrect.
The total mixture velocity is given to us.
Yes.
Okay. Also, we are having the we can able to get the this uh, rho b from the mass fraction because mixture density is given to us.
Yeah. Yeah, yeah.
So yb can be calculated.
See, first thing, you are saying mass flux of B, this thing is incorrect. This is not correct, bro.
No, no, this no, sir. This is not for mass flux of b, sir.
Yeah.
This is the relation, sir. You remove the mass flux of b.
Wait, wait, wait.
So we are having this relation, sir. I think for the binary mixture. That is, diffusion of the both the species are same, but they are in opposite direction.
They are in opposite direction. That is correct. That is correct. DAB into DYA upon DZ is equal to the DBA. Basically DBA. So you are saying this. If we write it like this,
But the problem here is, sir, we are not having the distribution of
just give me a
YB
minute.
in terms of Z.
Okay, okay. See, just give me a minute. Let me think. Yeah, this is correct. Yeah, this is correct. But what information you are getting from this formula? I don't understand what you are getting from here.
Sir, here the distribution is not there, so we cannot use. But we can use that formula, sir. The total flow rate, total velocity
Okay.
of the mixture equals to the mass fraction of A into VA plus mass fraction of B into VB. So from that we can able to calculate VB as we are having the VA with us,
Yeah. 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 Yeah.
or we are having the mass flux of A.
Yeah. See, yeah, I'm getting. I'm getting. You are saying you have the mass flux of A. You already got the mass flux of A, and that you said something like that. Mass flux of 4.6.
68 into 10 raised to minus 3.
Now you are facing the problem in calculating mass flux of B, or you have calculated mass flux of B.
Yes, sir, we can calculate it.
Okay, you calculate. You calculate and you tell me the final answer. And anyone else other than hers?
Sir, it is
Yeah.
5.32 into 10 raised to minus 3.
Mass flux of B is 5.32. Wait. Yeah, 5.32
32.
into 10 to the power minus 3. You are saying that, right?
Yes. Yes, sir.
Okay. Okay.
Is this correct, sir?
No. Your your first answer is correct, but second answer is not correct. Mass flux of B. See, first thing. Okay. I will solve it. I will solve it. It is not correct.
Wait, actually,
Yeah.
actually,
Yeah.
I have to consider the this what I can say.
Okay. 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 Okay.
Okay, forgot, sir. Sir, just a minute.
Yeah. And what about others? Others are you solving? Manish, are you solving?
Sir,
Yes, sir.
7.4. Is it 7.4?
Wait. Yeah. 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 Hers, it is 7.4 is correct.
Yes, I forgot to multiply that with the density of
Okay.
the
Okay.
mixture.
Okay. 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 Yes. Yes. Manish. Yes. Manish, you were saying something.
Nothing, sir.
Okay. Okay. Ijazul? Okay. 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 I will solve that. Okay. Okay. So, do you want me to solve, or what? What do you want? Should I move to the next question, or should I solve this question? Hello. Can anyone reply?
Sir, please solve, sir.
Yeah. 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 I will solve. Question number 8. Okay. So, if like while I am solving, if you are not able to understand any step, please let me know. suppose that there is a flow, and in that some bulk mixture is flowing, in that there are two gases A and B. Now the mass flow rate of A is equal to the mass flow rate of A due to bulk motion plus mass flow rate due to diffusion. Here it is A, mass flow rate of A due to bulk motion plus mass flow rate of A due to diffusion. So mass flow rate of A due to bulk motion, what it will be? Density of mixture into velocity of mixture into mass fraction of A plus mass flow rate of, here it will be divided by area, right? Should we divide by area or we should not divide by, sorry, should we multiply by area or we should not multiply by area? Okay, plus mass flow rate due to diffusion minus rho density of mixture into area into diffusion coefficient into d into ya upon dx is equal to the, this is mass flow rate. Now mass flux, how will you calculate mass flux from mass flow rate? How will you calculate mass flux from the mass flow rate? Hello, are you there? Yeah, Manish, suppose that is mass flow rate is given and you need to calculate the mass flux. How will you calculate? Harsh Patel, are you there? Am I audible? Hello. Ijazul Rahman, are you there?
Yes, sir.
Okay, so the mass flow rate is given and we need to calculate the mass flux. So we will divide by area, right?
Yes, sir.
So mass flux is equal to the, if you divide by area, it will come rho into V. This is the velocity of the mixture into Ya, mass fraction of A, plus minus rho into D into dya by dx. Now what they have given, okay, they have given, they are asking the that mass flux at Z is equal to the 0.1. So Ya they have given, we have Ya and we have V, velocity of the, what is the information that we are having? We have bulk velocity. This is a bulk velocity 0.01 meter per second, and they have given the density, bulk density rho. So just substitute the value, 1.2 into, this is 1.2 into bulk velocity. What is bulk velocity? 0.01 meter per second. 0.01 into Ya, mass fraction of A. What is mass fraction of A at Z is equal to 0.1? Guys, what is the mass fraction of A at Z is equal to 0.1? It is clearly given, right? At this one formula is given, Ya 0.8 into 0.8 minus 0.2, this will be 0.6, right? Guys, please speak, because if just I keep on solving, it won't benefit anyone.
Yes, sir.
Okay, okay. This YA, from here we are getting YA 0.8 minus 2 into 0.1, so it will be 0.6. It will be 0.6 plus minus rho density will be 1.2 into diffusion coefficient. What is the diffusion coefficient? 5 into 10 to the power minus 5 into dya by d, here it will be dya by dz, because it, like, they have given z direction, so it will be dya by dz, so it will be minus 2, right? It will be minus 2. Now if you solve, you will get the mass flow rate of A, sorry, mass flux of A. You will get mass flux of A, and it will be 1.2 into 2 into 0.01 into 0.6 plus minus 1.2 into 5 into 10 to the power minus 5 into minus 2. So this will be mass flux of A is equal to the 7.32 into 10 to the power minus 3. Mass flux of A. How will you calculate the mass flux of B? Same procedure. Do you want me to calculate, or you can calculate? Manish, are you there? Manish,
Yes, sir.
yeah, yeah. So can you calculate the mass flux of B?
Yes, sir.
Okay. Ijazul, can you calculate the mass flux of B? Or do you want
Yes,
me
sir.
to
Yes, sir.
calculate? Or if you want, I can calculate. Should I calculate, or should I move to the
Okay,
next
sir.
question?
Calculate, sir.
Okay,
Sir, keep it on.
okay, 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 no problem. Okay, mass flux of B. Just you repeat the same procedure. Mass flux, mass flux of B. Density, bulk density into bulk velocity into mass fraction of B plus minus bulk density into diffusion coefficient into d into y by dx. Bulk density they have given 1.2, bulk velocity they have given, what is the bulk velocity they have given?
0. 0.01.
Yeah, 0.01 into yb. We don't know yb, but we know ya. So, like, ya we calculated, right? Ya 0.6, so yb is equal to the 0.4, right? Yb is equal to the 0.4 plus, here we will multiply by minus density is equal to the 1.2 into diffusion coefficient. Diffusion coefficient, what is diffusion coefficient? They have given 5 into 10 to the power minus 5 into dy by dx, dy b by dx, dy b by dx. Now you just calculate 1.2 into 0.01 into 0.4 minus 1.2 into 5 into 10 to the power minus 5 into dy b by dx. uh, yeah, can you tell me what is YB? Because we know YA. We have YA. YA is equal to 0.8 minus 0. Sorry. 0.8 minus 2 into Z, right? YA. So what is YB? Do you have any doubt here? Izadu, do you have any doubt here?
No, sir.
So
Okay.
now dyb by dz, what is dyb by dz? What is dyb by dz?
0.4.
See, yb is equal to 0.2 plus 0.2 plus 2 into z. 0.2 plus 2 into z. This is not multiply. This is plus. This is plus sign. If you differentiate this is a linear equation. If you differentiate it, what you will get? You will get 2, right? This is plus, not multiply. This is plus, not multiplication. Hello? Is Arjun?
0.4 coming, sir.
Uh, see, see, this is yb is equal to 0.2 plus 2 into z.
2 into Z. Yes, sir.
Yeah, so it will come 2, right?
Okay, sir. That means the mobile calculators are wrong, sir.
See,
Just okay, sir.
just to differentiate this, you need not any calculator. You don't need any calculator.
Oh, yes, yes, sir.
See, suppose that
2 plus.
this is yb is equal to the 0.2 plus 2 into z. Now you differentiate dyb by dz. This will come 2, right? Okay, this will come 2. If you substitute 2 here, you will get the answer. Just so that the mass flux will be 1.2 into 0.01 into 0.4 minus 1.2 into 5 into 10 to the power minus 5 into 2. Here you will get the answer. 1.2 into 0.01 into 0.4 minus 1.2 into 5 into 10 to the power minus 5 into 2. 4.68 into 10 to the power minus 3. If you solve this, you will get 4.68 into 10 to the power minus 3. Okay, do you agree or not? Izadul,
Yes, sir. Yes, sir.
do you have any doubt here?
No, sir.
No. See, from next time onward, you bring your calculator and pen and paper, everything.
Okay, sir.
Okay, so question number.
Sir, what is correct answer, sir?
What is yeah, yeah, this is the correct answer. Whatever I am getting, that is the correct. This is the correct answer. Mass flux of B is equal to the this mass flux of A is equal to 7.32 10 to the power minus 3, and mass flux of B is equal to the 4.68 to 10 to the power minus 3.
Sir, dBA is not given, sir.
Yeah, 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 yeah. DB like AB is given, right? A and B are given, right?
No,
What
sir.
what doubt you are having? Yeah.
The binary diffusivity of A is given, no? I,
See, no. See, first you read the question. It is not given binary diffusivity A. They have given diffusion coefficient of A in the mixture. That's what they are given. Binary diffusivity is the binary diffusive 5 to 10 to the power minus 5, where it is given for A. They have given, see the diffusion coefficient they have given. That's it. This is the diffusion coefficient. That's it. They are not saying like diffusion coefficient of A and B.
okay.
This is simply they have given diffusion coefficient D.
So we can use it for DAB and DBA also.
Yeah, yeah, yeah. DAB. See what they have given diffusion coefficient of A in the mixture. Diffusion
Hmm.
coefficient of A in the mixture. They like it is not given. DAB is not given. D in the mixture is given. Diffusion coefficient of A in the mixture. That what it is
Okay.
given.
Okay.
Do you have some doubt?
No, sir. Got it.
Okay, question
Got it,
number
sir.
8. Yeah, yeah. Someone is asking some doubt. Yes, Manish, please go ahead. Manish,
Yes, sir.
you want to
Yes,
ask
sir.
something? Okay. Question number 9 we have already solved. Question number 10. Try to solve question number 10. See, in question number 10 and question number 9 are related to each other. It's easy question. Just solve it quickly, and we have one more question, question number 11, and after that we will stop.
Sir, it is 2.594 into 10 is to minus 7 kg per meter square second.
No, no. Okay, 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 okay. 2.59 you are getting?
Yes,
2.59?
into 10 is to minus 7.
Yeah, yeah, correct, correct, correct. That is meter square per second. That is correct.
Okay, yes. Yes.
Yeah, yeah, that is correct. But you have done a mistake, because answer is not 0.249. Answer is something else. That mistake,
Okay.
I know that what mistake you have done is like, uh,
Sir, I
uh,
calculated the rho infinity.
yeah, 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 yeah. That what see, like you need to calculate the average value of rho.
Okay, fine. Sir, but I think so. Sir,
Yeah.
uh,
I
so
like I will solve it. I will solve it. See, I
okay,
am
fine.
getting. I am getting. You have done the correct. Like your procedure is correct. What mistake you have done? Then just you have calculated rho infinity instead of rho average. That's it. Nothing else. If you are getting 0.249, that's it. That is the mistake you have done. But that's fine. No problem. I will solve it in front of you. And after that, just I want this answer from someone else. Can anyone solve it? See, it's a very easy question. If you see this, it's a very easy question. See, but you need data from this question, and the answer of this question is 0.924. So you have Vy. Now you just need to calculate binary diffusivity of water vapor is evaporation rate. See, the formula is we have the formula d square by dt is equal to the minus rho into d upon this is the gas density, this is the liquid density, minus 8 rho g into rho g into d upon rho into L into ln 1 plus Vy. Just you need to calculate this, that's it. Just you need to substitute the value and we will get the answer. And the Vy, like we calculated last time Vy, we calculated Vy is coming 0.924. 0.924 Vy is coming 0.924. So you write 0.924 minus 8 into density of gas into diffusion coefficient upon density of liquid into ln 1 plus what is that, 0.924, right? Zero point 924. 0.924. Just you need to calculate this and you will get the answer. We know the density of liquid, we know here rho L we know, just you need to calculate rho G. Just use that EV is equal to the nRT equation, from there you will get rho. Okay,
Sir, 2.306 into 10 raised to minus 7.
2.306 into 10 to the power minus
7
7.
plus 7.
2.306, yes, correct. Correct answer is third one. Okay, so okay, I will solve it. I will solve it. And okay, so how to calculate rho G? Okay, how to calculate rho G? We will calculate the rho G. In this case, see, this question is the part of question number 9. So here they have given like ambient pressure, ambient temperature 80 degrees centigrade. Okay. Okay, so we can calculate the rho at now we don't know rho G. We will if we can do this thing, or we can do one thing. Do you have any confusion in this equation? Rho is equal to the P upon RT. This R is not a universal gas constant. R is equal to the universal gas constant divided by the molecular weight. Rho is equal to the P upon R. This is the universal gas constant into molecular weight into temperature. Density of gas. Density of gas. See, yes or no? Please say yes or no. Do you have any confusion in this equation? This is R is the universal gas constant, T is the temperature, and P is the pressure, and M is the molecular weight. Hers, is this clear to you?
Yes, sir. Correct. Sir, it is RU
Yeah.
in the.
This is RU. Yeah, this is universal gas constant. RU. RU universal gas constant. U. Ijazul, is this clear to you?
Yes, sir.
Yeah. So we will get density. Uh, Now see, in this case, what m should be taken? We will take the average value of m. Molecular weight at, suppose that this is the droplet. This is the droplet. We can take the molecular weight of the mixture at this point and at infinity here. Suppose that this is infinity. So molecular weight of the mixture at infinity at y is equal to the infinity at y is equal to the infinity at very far distance we will take the molecular weight. So molecular weight at near to the surface, that will be summation of xi into mi. So it will come at the interface is 0.6 into water vapor at the interface 18 plus 0.4 into 28.84, right? 28.84. Now if you solve, it will come 0.6 into 80 plus 0.4 into 28.84. It will come 22.336. 22.336. Now this is the molecular weight of mixture at the interface. Now molecular weight of mixture at infinity. It will come here. The molecular weight at infinity. Molecular weight at infinity. So this will be now someone please molecular weight at infinity.
Sir, it is. Uh, how much? Yes. 28.73
Yeah.
total molecular weight.
0.01 into 18 plus 0.99 is 28.84. 28.84, and it will come. This is 0.01.
Sir, it is 28.73 all in all.
This is 0.01. If you do this, it will come 0.01 into 80 plus 0.99 into 28.84. 28.84, and this will be 28.7316. 28.7316. Now you take the average molecular weight, it will be 1 by 2. 28.7316 plus
22.336.
22.336. 22.336, and if you take the average, what it will be? $25.53. It will be 25.53. Now in this formula you just substitute the value. They have given the pressure They have given the pressure 1 atm, means 101.325 kilopascal into 25.53, 25.53 upon what is RU?
8134.
Okay. Other than you, can you tell what is RU, universal gas constant?
8314.
8.314.
8.3.
Yeah, yeah, yeah. 8.314 into temperature. To what is temperature? 80 degrees Celsius, right? Should I write 80 or in Kelvin? 353, right? 353 Kelvin. 353. Now you solve it, you will get the average density, and that will be 101.325 into 25.53 upon 8.314 into 353, 0.8814. It will come 0.8814. Now you you got the average density. Just you substitute here, you will get the answer. It will be minus 8 into density 0. What you are getting the density? 0.8814. Yeah, this is what you are getting. 0.8814, 0.8814 upon density of liquid. What is this? Liquid. Please someone else tell me the density of water.
1000.
1000.
Yeah. Into ln into ln 1.924. 1.924. What it will be? 4.614 into 10 to the power. No, I think I have done some mistake. 8 into 0.8814 upon 10 to the power 3, 10 to the power 3 into ln 1.924. 1.924. I think some mistake is there. d square by dt. This is coming to d here. This, yeah, we need to multiply with the d, diffusion coefficient t. Are you getting the mistake? What is the mistake? We need to multiply here d into d, right? Hello. Like it is multiplied by the d, right? Into d. If you do this calculation, like minus 8 into 0.8814 into diffusion coefficient. What is diffusion coefficient? What is diffusion coefficient? In question number 10, what is diffusion coefficient?
5 into 10 raised to minus
5 into
5.
10 to the power minus 5. So 5 into 10 to the power minus 5 upon 10 to the power 3 into ln 1.924. 1.924. Now you calculate this. Okay, so it will come 2.3071 into 10 to the power minus 7 meter square per second. Now someone convert this meter square per second to mm square per second, not hertz, other than hertz. Meter square, just convert from meter square per second to mm square per second. Okay, I will convert it. 2.3071 into 10 to the power minus 7. 1 meter is equal to the 10 to the power 3 mm square per second. So it will be 2.3071 into 10 to the power minus 1 mm square per second. So it will be 0.23071 mm square per second. Now 0.23071, so that is the correct answer. 0.2308, it is the correct answer. Okay, okay, so now our time is over, we need to stop. Like some questions are remaining, we will solve those questions in the next week anyway. So from next time onward, everyone bring your calculator and copy. Do not sit without your calculator, copy, pen, something. Okay, okay, guys.
Okay, sir. Thank you,
Okay,
sir.
okay. Harsh, wait, 1 minute. Okay, Harsh, you was saying something. I forget that. Yeah. See, in this question, you was saying something. One question was there. You were asking some doubt.
Was in which?
Yeah, yeah. This question you were asking some doubt. Yeah, yeah. In this question itself, in diffusivity, suppose that if you take the average of density instead of taking the average molecular weight,
Both are same, sir.
so you will get the similar answer.
Yes, sir. Actually I solved it by calculating the density at the far field and the at the interface,
And then you
and
took the
then I
average.
took the average,
Yeah,
and
and
the value that I got is similar to the value you
yeah,
calculated.
yeah, yeah. One thing, and second thing, even if you are calculating density at the surface,
Hmm.
suppose that you are calculating density at the surface. See, suppose that you are calculating density at the surface, not
Yes,
calculating
sir.
the density at infinity.
Yes.
You will get the different answer, but that answer won't vary much. It will vary little bit. And if it is a theoretical question, that is also correct. Why? Because if you see two, three different books, they have
Yes, sir.
defined it in different ways.
Okay.
So like in some cases, what they have said, like they are saying 2 by third law. They are saying like 2 times the density of near to the interface plus density at infinity upon 3.
Okay.
So even if you are calculating the density at the interface, you are not calculating the average. That is also correct, but be in the safe side. You calculate the average. That will give the more
No, sir.
more accurate
Eh,
answer.
Sure, sir. Sure.
And one more thing here, you are saying something. Question number 8.
Yes, sir. There is
Yeah,
a question. I am
yeah,
having the doubt the binary
yeah,
diffusivity.
yeah, yeah. See, suppose that there are only two. I got your doubt. Just give me a second. Suppose that there are two mixture. There are only binary mixture, right?
Yes, sir.
So some species are there. Diffusion coefficient of A in mixture.
Hmm.
We will 1 minus x into I upon summation of xj upon dij. This is the formula to calculate the diffusion coefficient of ith species in the mixture.
Yes, sir.
Now there are only two species A and B. In the mixture, only two species are there, A plus B,
Okay.
right? So what
Hmm.
is, if suppose that I have given uh, uh, like mole fraction of A is equal to the 0.3, then the mole fraction of B is equal to the 0.7, right?
Yes, sir.
So now you calculate division coefficient of A in mixture. diffusion coefficient of A in mixture, it will be 1 minus, now, now 1 minus 0.7, right,
Yes, sir.
upon
No, sir, it
diffusion
is 3, no? It is 3, sir. If A is in a question, it should be 1 minus 0.3.
yeah, yeah, sure, it will be 1 minus 0.3, it will be 1 minus 0.3 upon, now there is only one other species, right,
Hmm.
now that is what is the mole fraction of that species?
It is 0.7.
0.7 divided by
The diffusivity, that is, let us say, some arbitrary value x. Yes,
diffusion
DAB.
coefficient of A in B, right,
Yes, sir.
now it is 6, okay,
It
now
is DAB on.
0.7 upon 0.7 into diffusion coefficient of A in B, so
Huh.
it will come diffusion coefficient of A in B, so
Yes, sir.
so what we can say that diffusion coefficient of A in mixture in the case of binary mixture,
Hmm, hmm, hmm.
A in mixture is equal to diffusion coefficient of A in B,
Yes, sir.
so that's it. So if they have given the diffusion coefficient of A in B, it means the diffusion coefficient of A in mixture is given, so you need not to think it. Do you agree or not?
Okay. Yes, sir.
Yeah, do you agree or not?
Then, sir, what about the mixture that is DBA? My question was in that only.
You are saying dBA is equal to the minus DAB. dBA,
No, I'm not saying. I'm not saying. I want to know that.
yeah, yeah. dBA is equal to the minus DAB.
Okay, it is from the both are in the both are same. The direction is reverse.
Yeah, yeah. So
Okay, fine, sir.
this,
That is.
this okay, okay, okay.
Uh,
So remaining question we will solve in the next week. Okay, okay. So if you have any other doubt, now you should not ask the doubt because time is over. So we will discuss next week. Okay,
sir, in the solved part,
yeah.
mm, the second, I think it is the second. Just a minute, sir.
Where it is?
Yeah, in the very first question itself.
Yeah. Wait. In
Okay,
very first question, yes. Yeah.
sir, in the calculation of YFS,
Sum of
the
diffusion
bulk.
masses of, yeah, what first question? First question you are saying, right?
No, 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 sir. In the solved part, in the video.
See, Harsh, now you should discuss in the next week because I have some other work.
Sure,
It is
sir.
already 8:15, more than 8:15.
No, no, no problem, sir.
Okay,
It's totally fine.
okay. Thank you.
Thank you, sir.